Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 51. And today I'm joined by Ian Cooper to chat about his open source library Brighter. Now Ian joined me back in episode 17 to talk about test-driven development, which was quite a popular episode. And thankfully it looks like I didn't put him off too much. So welcome back Ian, thank you for joining me again.
Hey Dan, nice to see you again.
You too. So for those that missed the first episode or don't already know who you are from various talks and community stuff that you do, could you introduce yourselves to the listeners and talk a bit about what you do?
Yeah, sure. So my name's Ian Cooper and I have been a software engineer for quite a few years now. I think it could be close to 30, I suspect. Yeah, I got a lot of grey in my beard now. And I used to have more hair on my head when I started this. So you can, if you go out there onto the videos out there of me doing various talks, so I talk quite a bit at conferences. I was very lucky to get into conference speaking because I was a C++ developer. I worked in fintech in the kind of 90s. I started my career in healthcare and then went to fintech in the 90s. And both Java and .NET kind of came out. And because I was more in the Windows space, I got into .NET very early when it was still in beta. And I was on various mailing lists and we were all very excited by this idea of not having to do things like memory management ourselves and, deal with basically pointer arithmetic. So we were all very excited. And there was a post to one of the forums about .NET saying, hey, the Dallas user group's meeting up tonight. Who's going to be there? And I was like, oh, that's cool. I must go to the London user group. So I put a post in saying, hey, when does the London user group meet? And somebody said, well, there isn't one, but if you start it, I'll come to your meeting. So I contacted a few folks in the US who ran them. Developmental, which I don't think exists anymore. I'm not sure. Helped me out. Said we can use the offices. But when we started, of course, there were no experts. There was no one even at Microsoft, really. There were a few people we eventually got in touch with. So we had to kind of do our own talks. So it was like a question of well, who's going to do something next week? 10 minutes on something they've discovered in the framework. So I got used to with a quite, collegiate sort of atmosphere, standing up and giving a short presentation, what we think of nowadays as a kind of lightning talk. And then we began to give slightly longer talks. We invited people who knew what they were doing to speak, so you'd learn by watching them. And that then got me into the first of the developers, DDD days in the UK. And that then got me from being seen doing that into speaking at NDC. So I've been traveling and speaking at conferences ever since. And it's great because you do get to refine your thoughts on something in order to be able to teach it to somebody else or present about it to make an argument to somebody else. So I guess, a lot of people know me from that test-driven development talk. But yeah, I've sort of done quite a few over the time, and I always say you can look back at my videos and you can see a progression of Ian basically all clean cut with hair on top of his head to Ian with basically long grey beard and piercings, etc. And a few people out there will occasionally post before and after in the software career memes about me. So yeah,
I feel if we take your webcam view and just turn it upside down,
I would have luxury hair. Yeah.
I think the first time we met, I remember it was one of the DDD conferences, and it was near the end, and there was when everyone's starting to leave, and I remember in the corner near where the slide deck was, you were sat there, and there was a swarm of people around, and you were talking, and there's something it looks like he knows what he's doing because everyone's listening and everyone's intently, and you just sat there completely chill, chatting away. So I think that was the first time I saw you in person, and then obviously you've been to .NET Oxford and spoken there a couple of times now, I think.
I think it's a few, yeah. I mean, Oxford's quite close, really. I mean, in terms of travel, it's pretty easy to get to, isn't it? So you're one of the easier user groups to come and visit.
Yeah, well, we've just started going back in person again because obviously lockdown and everything, we were on Zoom, and we're not doing every single month in person now. We're kind of alternating. Yeah,
so we just started London up again, and it's a bit trickier to navigate because, of course, particularly in London, because the commute is so painful usually, the number of people who are going into the office every day is quite small. So whereas before people went into the office all the time, we'd say, hey, we're going to be there on this Thursday. It was almost like, well, I fancied a beer anyway on the way home. I'll pop along to London.net, chat to a few other .NET folks, see a talk and go for a drink with them. But now it's more, I've got to ask you to come in on that day, make that one of the days you do come into office so that you come to our talk in the evening. So a bigger barrier to entry, I think, to in-person user groups than there used to be. But at the same time, also, I think there is a core group of people who have missed face-to-face interaction who are very excited it's come back.
Yeah, definitely. I think as a speaker, actually being on stage doing your talk in front of real people, you can see the interactions. You're not speaking to like a webcam or anything. That makes a massive difference.
Yeah.
But I can certainly see from, even as an organizer, it's in the past where I've been working in Oxford and then I finish work and just go into Oxford and we do the event, where now I'm working from home, which is, I'm not that far away from Oxford, but it's a bit further, and just used to working from home and not having a commute. Then even me as an organizer, it's kind of, it feels like a bit of a chore to actually get all the way to Oxford to do .NET Oxford. And then once I get there, it's worth it because it's like the same old faces and we can catch up and everything.
So I think there's an interesting thing, right? I think one of the things is, of course, the user group in-person meeting in a post-pandemic age, and a post-stage of YouTube to some extent, where you can get a lot of content just by going to YouTube in your own home and watching it, is the interaction, right? And that's an interesting thing for us to think about as we go forward as user groups that have an in-person kind of component, is how do we emphasize that part of it, right? How do we emphasize? And I think, one of the things that we may want to play into there is this: when we first started London.net, a big constituent of our user group were quite often people like contractors or folks actually working in very small, where they were the only developer, because they just wanted someone to come and talk to about development, etc., almost down the pub afterwards, right? And have a moan with somebody that understood their pain, right? And I feel a little bit like that's one of the things we should probably emphasize about in-person user groups is, hey, look, we are going for a chat afterwards. I think the only thing in the UK we need to think about in 2023 is, does that always need to involve alcohol? Because that is a question we've, I think, not really challenged ourselves enough with, is can we have that social interaction in the UK at post events where we don't always demand that is based down the pub, which excludes a lot of people. So it's an interesting question.
Yeah, I guess if you kind of went the other way and it wasn't down the pub, it was something else, then that would also put a lot of other people off that actually enjoy, just especially if it's like in a town centre and people enjoy going to the pub and having a pint whilst just geeking out. It's a double-edged sword, really. I can picture that putting a lot of people off as well, not having it down to the pub, because that is an attracting factor to it, I guess.
We need to balance, I think, basically, just have a variety so that there are some events that everybody feels comfortable with.
Yeah, definitely. The sponsors for our event, they actually provide the venue and food and drinks and everything, and they always make sure that they provide soft drinks as well, and even non-alcoholic beers, so that they've got a range. Because a lot of people, like, even if the only reason for not drinking is the fact that they've driven in, they still want to feel like they're having a drink or something and taking part. And then,
yeah, non-alcoholic beers are actually quite nice now.
You're drinking a different non-alcoholic beer than I am then. So we should really talk about Brighter then, and I guess the counterpart Darker. Well, it's probably not the counterpart, is it really? But we can get into that as well.
Yeah, we can get into what the difference is. Yeah, sure.
So as an elevator pitch, what is Brighter?
Okay, so Brighter is and Darker its sister. Brighter is a framework for essentially commands and events, and you can either use them in an internal bus, and by that we would mean just in memory in your application. So one part of your application, rather than a web API controller, for example, rather than exercising your domain model directly, raises a command, and that command basically is what actually exercises your domain. Or some part of your domain has finished exercising a command and wants to trigger other parts of your domain, and so it raises an event. And our sweet spot is we can do that as an internal bus in memory. So that's the equivalent of something like Mediate, which I think a lot of people know, which is all in memory. Or we can do that basically out of process, which is the equivalent of things like mass transit and then service bus. We make that fairly straightforward to kind of switch between one and the other. So we use send to be, hey, it's a command with one target, and publish to be, it's an event with multiple targets. But we use post to say, either my command or event is actually going to be handled out of process. And what lives in between you and the thing handling out of process is some message-oriented middleware. And we support a range of them. So we have a range of what we call transports, and We support, for example, AWS, Azure, Rabbit, Kafka. Those are ones that are, the most frequently used and well tested. We've also got some ones that are less commonly used around, things like Redis. And we're always happy to add new ones. There are a couple in flight. MQTT is currently in flight.
It does sound very so there's two technology libraries you mentioned, Mass Transit and Mediator. I've used them both before, and I must confess, up until today, I've not actually used Brighter, but it's been on my list for a long time to play with. So actually doing this podcast has been a nice excuse to have a little play with it, which I've been doing today. And I really like it. So because I've been used to those two libraries, it felt the concept felt very familiar. And I really like the whole thing of having like a handler class where there's just one method with the application logic and it's the framework that calls it. And the handler doesn't need to know or care what triggered it, whether it's a message on a queue or it's an API call. The handler just doesn't care. It's single responsibility principle. It's very clean. And you can use DI in that class. And it's just that same pattern, which when I've used Mediator, it's obviously the same kind of thing with mass transit and the consumers in mass transit. It looks very, very similar. And also, playing with Brighter today, it's the same kind of concept where you've got this handler with a method and you can put your stuff in there and the system calls it. I just think that's a really nice pattern, very clean.
Yeah, I mean, we all have slight differences. I mean, we predate Mediator, but I think we are about the same time as mass transit. There were earlier .NET projects that we learned from, like Fubu was one of the ones, which Jeremy's got a kind of new version of called Wolverine out right now. But I think many of us were operating in that same space. We were, as a .NET community, putting our toes into the water of CQRS and that kind of thing. So these things were definitely coming up. But with one of our kind of design goals was this. We like the way, if you are a .NET developer, when you want to write a web API, you just write a controller, right? You don't have to really get into the depths of the HTTP that is underlying it. I just write a controller, I set it up, configure it, and effectively those HTTP messages get received, essentially turned into basically a call to my code. And we thought, well, that's really how messaging should work, right? Particularly for a consumer, you shouldn't really have to know anything about message pumps. You shouldn't really have to know anything about the details of a particular transport and how it works. All you really want to do is write the code that runs when you receive a message and then have us handle, well, how do I do that in a way that is essentially reliable and performant and consistent? So hopefully when you look at the way we work, you'll see that some of the design ideas come particularly from the kind of ASP.NET model. So we use attributes on that handler method to let you control things like a whole pipeline of orthogonal steps middleware, right, that runs for your handler. So hopefully you're familiar with the concept of middleware, and we let you configure it with attributes. So one of the attributes we let you configure is to use a policy. And what we do there is we say wrap your handler in a poly policy. Now, poly policies, everyone, I think, in the .NET community really got familiar with when ASP.NET adopted them. But we were a really early champion of poly. And I used to hang out with and speak to Dylan about it a bit. And we loved it because for us, when we looked over in the Java space and what Netflix were doing with things like Hystrix, we really wanted something that gave us that kind of support for retries and circuit breakers. And we saw this thing and thought, that's great. We can wrap any given handler call in those facilities. But we want to make it simple. You don't have to wrap all your code effectively in the poly code. You just put an attribute on your handler saying, I want to use this policy, and we'll do all the work of wrapping for you. And there are some features today in Poly that we actually built in Brighter and Dylan looked at and then extracted those to be general Poly features. So that's one of our early sweet spots, was this idea of saying we want to make it really simple for you to configure a middleware pipeline as a series of attributes. So it feels very familiar if you're an ASP.NET developer, but it lets you introduce these ideas like logging or retry or falling back to a method where if you basically execution fails, to take some action at the end in a very simple way.
Yeah, that's very cool. I'm assuming where I said I used mass transit before, one of the reasons I kind of like using that kind of abstraction, and I'm assuming it's going to work the same with Brighter is, for example, one project I'm working on locally in dev, we're using RabbitMQ. For QA and production, we're using Azure Service Bus. But the code, pretty much all the code doesn't change except for a little bit of Bootstrap in program.cs where it sets them up. I'm assuming it's the same kind of concept with Brighter.
Yeah, so exactly the same. So the hardest part, and we were having a little bit of chat before it began, the hardest part usually of what you're doing is in the kind of startup or program CS file where essentially you have to configure everything, right? And we have a notion of a publication and a subscription. So publication if you're producing messages, and a subscription if you're consuming messages, where we have to configure, well, what am I listening to, right? I'm listening to a Rabbit endpoint, or I'm listening to an AWS, basically SNS endpoint. You have to configure that, and that tells us what you're actually listening to or producing to. Once you've done that, it's fairly straightforward. Then you're basically just writing code to handle the messages that get produced. I mean, we all have slight variations. So mass transit from memory has a slightly more fluent syntax in that sort of more classic teens era when DSL fluent kind of style configuration was very popular. We stuck slightly more to what we felt was more familiar to ASP.NET devs, and we stuck slightly more with an attribute-based model. But at the same time, things evolve. I mean, we are keen, I think, to look at what minimal APIs give and say, well, if our design goal is to try and be familiar to the ASP.NET dev, to have a similar approach, we need to, in probably V10, think about addressing how do we work in a kind of minimal API way as well as our classic way. And we might, our current thinking is we would probably use CodeGen so that actually you build something that looks very much like it would have done, but without having to necessarily write the class that basically contains your handler. You just write the handler, and we would then basically code generate the class that wraps it, for example. So the debugging experience would be very similar to what it is today.
Yeah. I've still not, speaking of minimal API, I still default to using controllers and everything. I don't know, it's the whole one.
They're a bit Marmite. They're definitely a bit Marmite.
Yeah.
I think that for a level of complexity, it's easier, and at another level of complexity, it gets harder. And I think that's always been true of those kind of fluent style approaches. If you have low complexity, it's really quite straightforward. Once the complexity grows, switching to the other model makes a lot of sense. And I suspect that some of what, we could ask them about this, some of what the ASP.NET team were aiming at were in a kind of microservices world where I've got some small service that is essentially hosted in a Kubernetes pod that I don't necessarily want to write a full-on web API style service. I'm just doing some chatty internal HTTP communication between two services, and hey, something simple will do me, right? And that level of complexity, I don't necessarily want all the things I might with a public web-facing HTTP API. And given we are used in that context a lot, right? Something like Brighter is used in the context of service-to-service communication for doing that kind of middleware stuff. It's definitely something we might want to try and learn from. But while we're talking about external buses, obviously we can be used in an internal bus scenario, and we, much like Mediator. The big difference to Mediator is that we distinguish, we're slightly more CQRS-y. So Brighter in that model is essentially says you want to effectively potentially mutate state, and Darker, our sister project, says, hey, I want to query state. And they're very similar in the way they work, but it's just that the interface is different. So with our commands, we don't expect effectively return value, right? With Darker, with the query, you have to define what the return value is that you're going to receive at the same time. And our usual expectation, if you see a lot of our sample projects, is that you use both, and typically you'll mutate something and then query something to give a result back to somebody. That does create a little bit of funkiness in one condition, which is if you're using something like SQL identity columns to generate IDs, so you're not using a GUID or whatever to be the ID of the thing you're creating. If you then want to query it, how do you get the ID back for what you just created with the command? And we do have some easy workarounds for that. One of those is just actually in the command, effectively have an out parameter, because you see the command afterwards and fill in that ID number and then read it off the command and then do the query. But that's only a little bit of funky stuff. But we have otherwise quite distinct what you think of as command query separation in the two.
So if you're like abstracting over like RabbitMQ or some message broker and you're doing a query, does that then have to send a request back?
Yeah, so one of the reasons for separation is that we don't do Darker over a messaging middleware, because
I see.
that query model becomes less sensible. Now, you could do it, right? And something like Rabbit, right, what you would do is we would have to basically send the message. There's a reply to header. We would basically create a private temporary queue. We'd receive the response back, and we'd have to block waiting for that response and give you the query back. We don't really want to go down that route, because we do support on the command processor call method, which will do that for you if you are desperate to do that kind of RPC syntax. But the normal messaging model is send a command and listen for an event, where the event is the response back to that query. So another reason for the kind of separation of Brighter and Darker is because Brighter is sending a message and you have to listen to an event in response. Essentially, the kind of query interface wouldn't make so much sense. And so that model is then in Darker, where we do, hey, I just want to query my data store. Right?
Yeah, that makes sense. I know with mass transit, they've got this whole like request response model over a message broker. And I must admit, I don't really like that. So I kind of avoid that side of things.
Yeah, I mean, it's theoretically possible, but under the hood, you're just blocking on a response over a given queue. So we tend to say it's probably best not done. We do have a method called call in Brighter, which will do it, but we don't tend to recommend you use it. It's kind of the get out of jail clause for someone that desperately needs it.
Yeah, I tend to, like, if I need a response, I'll do it like a gRPC request or something instead.
Yeah, I mean, so messaging has a classic pattern, which is I send you a command and I wait for a response, and I use a correlation ID to tie the two together, right? So less people understood that in a pre-async world. In a post-async world, I think everyone gets basically post-async await this idea of saying, well, over here I'm sending a request, and at some point later I'll get a callback over here, and then I'll execute the code that is in response. And so messaging does do that pretty well, although we tend to have some other techniques a lot in messaging. So we explicitly do for you, but there's a technique called event carrier state transfer. So the idea with event carrier state transfer is typically if I'm building an event-driven architecture, one of the things I want to avoid doing is an HTTP GET between my services. Why is the question? Well, the reason I want to avoid an HTTP GET is that creates what we call temporal coupling. So that means any call like that, any synchronous conversation, right? So if you get async await, it's about conversations. So a synchronous conversation, both parties have to be present. And an asynchronous conversation, which is messaging, both parties don't have to be present. So the parallel is a synchronous conversation is a phone call. Asynchronous conversation is WhatsApp or Telegram or Signal or whatever your preference is. Right? And the advantage of asynchronous is because the other party doesn't have to be there, I'm very resilient to their failure, right? They're not there, that's fine. My message basically goes into a queue waiting for them to basically look at it when they can. So as soon as I introduce an HTTP GET, I say this service is dependent on the uptime of the other service. If what I do is say, well, I don't really want that, I want to be independent of that other service's uptime, I create a bulkhead to failure is the way we think about it. Then the other thing I can do is say, well, rather than making a GET request to it, I will ask it to publish events about the things that we all might want to know. I will listen to those events and build what's called a forward cache or sometimes a projection. And I can just locally to me, and I can look in my local store to get that information. Now it's important what we understand, we're not doing any kind of database replication. So really what I'm caching is what you would have given me had I done a HTTP GET to you. You'd have given me this result. I'm just saying to you, could you give me those beforehand and I'll cache them, and then I can just look them up locally when I need them. So it doesn't work for something where there's a runtime calculation based on now, or there's some kind of Cartesian. So I currently work for Just Eat Takeaway, and understanding whether a restaurant delivers to you, it would be difficult for me to build a big table somewhere that said every place in the country I'm going to figure out whether I can get to it, they can deliver to me. So I have to look up real time. But otherwise, you can try and push this stuff down ahead. So that's one way of avoiding that problem of you needing to do a query call, right? Because if rather than saying, I'm going to ask you and you're going to send me the information, which works in messaging, right? You're just queuing up your request, someone answers it, you get a response back. Sometimes if you just subscribe, then I've got the thing locally before that I need anyway. Right? But messaging will do a request response. Just don't block. Just don't block in a kind of cool syntax when you do it.
That's the thing I'd be worried about. If the sender or the publisher was expecting a response and it just hung if it didn't get one, then I think it's just having, as you architect a system, having awareness of what happens if it doesn't go down the happy path and just thinking that through as architecting. But yeah, that's quite a nice pattern with the caching. And I guess it's kind of, even if service B is caching the thing and it's still calling out to service C, and it only uses the cache if it fails, it can still, there's various different patterns around.
Yeah, so that's definitely a pattern I've seen sometimes, is to say, okay, you can do that generically. You can say, hey, I'm going to call a history uses for Netflix. I call this other service. If it's not available, what was the last good result I had, which had the same parameters? If I stored that, I could serve that result instead and hope that stale result was good enough.
I guess the downside there is that if the very first request fails, then it's got no cache data. So it's kind of where, I think your version where it's getting the data and caching it, and that's kind of the temporarily source of truth.
Yeah. So yeah, I think one of the concerns people have with that kind of model is eventual consistency, right? When I deal with messaging a lot, and one of the problems you get in terms of perception is people go, oh, I don't want to use messaging, it's going to be really slow, right? I just make an HTTP call, that'd be faster. And you're like, why do you think it's going to be slow? So there are a lot of answers to that particular problem, but let's kind of work through them. So the first thing is, obviously, I'm putting the request from service A to service B will go on a queue. But really, you don't want a lot in that queue in terms you want it to back up a long way. The queue's purpose is to hold the message if service B is not there. It's not to make service B wait, right? And you can apply back pressure if service B looks into a, say, constrained resource. So let's say it's got a DB connection pool, it can only process some things so fast. You can use it for back pressure, but unless you want to use it for back pressure, generally what you want to do, have enough processing of the queue so that whatever your rate of arrival on the queue is, and given your rate of execution, you have enough consumers, with a thing called the competing consumers pattern, to read the queue fast enough that you can control the latency. Now, there's a thing called a queuing theory calculator. So queuing theory just takes that calculation and adds a bit of a Poisson distribution. You can find them out on the internet. And it will tell you, in order to get a given latency, how many readers of the queue do you need, right? And if you then add together the queue latency for outgoing, processing, and then response, it's not necessarily going to be that different to an HTTP call going back and forth. But you have some reliability in the event the other service is not there, that essentially your question is eventually answered. Now, it may be that eventually answered is no use to you, right? Which is the whole, well, when I query you, if you're not there, it doesn't matter to me that you will answer me in 3 seconds. The fact that you haven't answered me now doesn't help my customer at the other end. And that's where effectively the ECST model helps, where it says, well, because I've listened to you in advance, I've got this local cached version, and that is how I can respond. And people say, well, that might be stale. And you're like, well, yeah, but everything is stale, right? If I make a GET request to you and I get a response back in an HTTP body, that's stale, because immediately after my GET, someone could have made a post to service B, updated the data, and the data I've received is no longer the same as the data that service B holds, right? It's the nature of distributed systems. As soon as you are distributed, you must deal with eventual consistency to some degree. So you have to really cope with the idea that your response could be dealing with stale data. And so things like versioning become very important, because you have to say, well, which version of data did you use to create this request? Which version have I got? Am I able to respond right now to that problem? But I think one of the problems that event-driven architecture has overall is that these kind of concepts that you need to start to dig into, there's a whole barrier to entry of an acquisition of some knowledge, whereas most devs, because they have come from an environment where they've had to serve web requests to customers, get HTTP, they understand how it works, it's bread and butter for them. And so I'm now asking you to learn a whole new set of patterns and approaches in order to succeed at this. And it feels like it's just going to be easy to do HTTP. That's the thing I know. And that's the big problem I guess we have in the messaging space, is that kind of barrier to entry of, but how do I succeed at this? But I'd always say, start light, right? It's the same way we all learn stuff. When I started messaging back in the 90s, and I worked for a fintech, and we built risk management software for mid-tier investment banks. And my boss came to me one day and he said, there's this new product, IBM MQ series. I can't remember what it's called now. It's something else. IBM have rebranded it to. It's like a message queue. We don't know what it is, but we know the banks are telling us we need to start using this so we can help integrate with them. I got given this manual, this IBM manual, and told to figure out how to use it. And I had no idea, right? I could make it work, but I had no idea how you would use this. Unfortunately, there was a guy called Marcus Rainbow, great name, and Marcus, taught me all about brokers and pipelines, and that was kind of the start of my journey. But there was an enormous body of knowledge to have to acquire to be able to suddenly use this stuff beyond, here's a manual, I can put something on a message queue, I can take something off, to understand what does that mean. And I think that is the slight problem for messaging. So yeah, I mean, we certainly see that. We see a number of people that essentially just use Brighter as a mediator alternative, right? And why do they want Brighter as opposed to mediator? Mainly because we have a middleware pipeline. It's what we call a Russian doll model, and that is that each pipeline component encompasses the next pipeline component. So if you think about a try-catch block, essentially inside the try-catch block, I call the next component, which could have a try-catch block, which inside the next component. And that lets us do things like use poly, because we can say, well, you can wrap all the later steps. So some folks like us because we have that distinct Russian doll pipeline.
So is that almost like in ASP.NET middleware, where you've got it's calling next within the method?
Yeah, exactly. So if you use our request handler, one of the things if you write a request handler, the code you write, and you want to be able to execute, in theory, things that happen after your handler, there's basically, you call the base type when you return in order to pass the call along, right? Now, most people don't tend to run something after, because essentially it's a Russian doll model, but it exists if you needed it, right? There's an interesting debate. Somebody on the .NET team was talking to Jimmy about Mediator and saying, hey, can Mediator do that? And Jimmy says, it'll never do that. And we said, oh, it's okay, Brighter does that already for you. But yeah, so that's kind of where we find a lot of people using this, because they want the middleware pipeline and they want the distinction between the C and the Q, the CQS style. And then there's the group beyond that says, hey, I'm actually wanting to do messaging middleware, and it turns out you give me most of the stuff I need to do that. So what Brighter will give you is the easy kind of way to, when you think about it, is Brighter is like, oh, I just want to do post, right? And that puts a message basically over middleware. We actually tend to recommend you actually use the split version of that method, and it does basically a thing called deposit post, and it does a thing called clear outbox. And why does it do that? Well, there's a problem in messaging, which is if I change some state in my database, like I say, update the order to pending payment, and then I then send a message. So say I may send a message basically to my accept payment service saying, please take payment. My code in this service now assumes there's a message downstream and I'm waiting for a response to come back. And when I get the event back saying payment was accepted, I'll mark it as done and move on to the next thing, or payment rejected and I'll do the next thing, right? But it could be stuck there forever with no message having been sent, because potentially my call to the broker to send a message failed, right? So I could have all the transactions I want in the database, but if my call to the message broker fails, the customer's order is never going to get advanced. So how do I get a way of saying, okay, if my change the database order status to pending, I have sent a message? And the problem is nowadays, because we don't have closed shops with one provider like Microsoft giving us all the kit we use, is there's no way to get a transaction that works across both my messaging framework and the database. This is where the thing called the outbox pattern comes in. And the outbox pattern says, well, rather than writing the message directly to the broker, I'll write it to an outbox table. The table I can put in the same transaction as your entity right. Okay. Now I've written those two things, what I can do is have something that reads from the outbox table and then posts any messages that haven't been dispatched for me. Now what we recommend you do actually is two-step. You basically get things written to the outbox along with your message. We recommend probably you just immediately do our clear outbox, which basically says, hey, flush the outbox for anything I've got inside it, which reduces the latency. And in another process, you run our sweeper, which says, I look for things that didn't get sent and I send them. So if your clear outbox call fails, just let it fail, right? Keep your entity written in the data store. We will eventually send the corresponding message downstream for you. Distributed system problem, you have to be prepared for duplicates because I might send the message and then fail to write back to the outbox table I dispatched it. So in theory, you can get duplicates downstream now. And that's why we talk about guaranteed at least once delivery, because it's really hard to do guaranteed exactly once. We do provide an inbox. So what you can do on a listener is attribute your handler with an inbox that says record things that I've seen, generally by ID, the message. So if I've seen it already, don't execute it again. And that gives you exactly once. Right? And the outbox pattern, the complexities for the implementers, Ask, Mass Transit, and Service Bus is usually around integrating with your transaction. So there's a little bit of config we have to do, particularly around EF Core, where essentially to help you say, okay, I've got a transaction and I'd like to put the outbox in the same transaction. Thanks very much. But we've got examples of how you do that. And we work with Dapper and EF Core and the sort of the main ones you likely want to use. And that gives you that kind of correctness when you are sending. And then there's the consumer, where we do a lot of work for you. We call it a service activator. That's just a technical pattern name. And that means when your code is run, when an external signal that you're just, your code is just sitting there spinning in a loop, something happens, we run your code. Something happens, run your code. So we do all the hard work of running what's called a message pump. And a message pump does a standard set of things. It gets a message off a queue. It translates the message. By that we mean the message on the wire is probably JSON, or it might be a binary format. And you want to take that and you want to convert it into a type in a .NET type. Right. Same thing that if you use an ASP.NET Web API controller, you're not looking at the raw HTTP, right? The HTTP is being converted into a type, the post body, and that's being presented to you to basically deal with. So we turn it into a type, so a command or event in our parts in the system. And then we dispatch that. So then what we do is just invoke that command processor that you're using on the internal bus, right? So that internal bus effectively is what we then fire, but we've listened to something external to fire the internal bus, and you then calls your handler. So whether you're on the internal bus or the external bus, it's the same model. We have a command dispatcher that says, hey, this command or event needs to go to a handler, find the registered handler, send them the code. But you can either invoke it by, hey, we're internal and I'm doing a command processor post or send or publish to it, or you can be external, in which case we run the message pump, which basically pulls something off the queue, creates the command, and then invokes the command processor to push it to your handler. So it's exactly the same process. We're just handling more of that for you. And then what we try and do is make that as reliable as possible. So for the really well supported transports like Rabbit, Kafka, AWS, Azure, we've got quite a lot of time and experience of doing things like your RabbitMQ cluster just died, that's fine, we'll cope. And that's really our distinction between that and the ones that are less well used. The ones that are less well used, like Redis, etc., there's always a bit more. There are a few people out there using it. We're not getting the same level of feedback. We aren't sure how. We therefore can't tell you how production grade it necessarily is. But the other ones, we can say to you, they stand up every day and they deliver millions of results for customers out there.
Yeah, I think the thing I like though is, like you've just said, a lot of stuff that the developer no longer needs to concern themselves with. So you mentioned before about people that were used to using like REST and that kind of stuff, and now they're trying to get into event-driven architecture and the complexities of a distributed system, how they've suddenly got a lot to learn and kind of things, even though they still kind of like need to understand the concept, because they need to understand, when I mentioned before about happy paths and what happens if something goes down. There's a lot that they also don't have to understand, because things like Brighter or mass transit are doing. And like where I said earlier, I've been playing around with it. I literally created 2 classes. One which was a handler, which I could just, it was a class I could put some like my code in there, which obviously I just did the initial console.writeline hello world, and then effectively a DTO. But it's just 2 very, very simple classes, and everything else just works for me.
Yeah. So with the command dispatcher model, what you're effectively doing is you're saying, I want to separate the parameters from the method body, right? And you're saying, rather than have, a call with parameters on it and then method body, what I'm doing is taking those parameters and I'm putting them in an object, which essentially is your switch. So our base class is called request, and we derive a command and event from that. And command basically is one possible executor, and an event is many possible executors. So command goes to send, and event goes to publish. So we're just typing to use typing to control that behavior. But just the parameters, just the parameters to the call that you want to make. So usually at the origin site, you know what the parameters are you want to pass, right? And in the handler, you've got the code you execute in response to that call with the parameters. And that separation of the two lets you separate from, say, being inside a controller where you're dealing with HTTP and saying, hey, I need to exercise my domain. You can effectively just raise the parameters, and over somewhere else in your handler is where you actually execute your domain logic. And there's a nice cleanness of separation there. It helps with testing as well, because I can write a lot of my domain exercising tests at that level, and then I can really worry, well, the controller just needs to essentially produce this message. I don't actually need to know where it goes. I just need to know that it raised it, right? And that simplifies a lot of your logic around, say, testing a controller to say, I just need to know it raises a command with the correct parameters, which can be really helpful.
Do you have, if you're developing using Brighter, do you have like a test harness kind of concept where you can simulate and verify that a message has been received or something's been invoked?
I mean, we do in our own tests, which you can go and grab them from. We've got quite a few like spy command processor. I don't think we surface one directly out of Brighter as a, hey, here's a testing helper. And that's not a bad suggestion. We have got loads of them in our own testing library, so we could, in theory, surface it so you could actually use a spy command processor to say, hey, what actually got raised to me. But it's fairly simple. I mean, command processor doesn't have a hugely complex interface. So even writing a simple fate that just says record all the things that were passed in to send a command in a big long list and then just check them afterwards is fairly straightforward. That's what we do. You can just cut and paste our code from our tests. We've got a lot of tests, so you could go and look in there, and that would help you do that. But you also managed to raise an issue for us, Dan, in your adventures. That was quite entertaining for both of us. For the listeners, kind of at the start of the podcast, Dan was saying, I think I found a bug. And I was a bit like, oh no. So we've got it's a really good one actually. So we got a new release out, and it went through pre-release, and we just come out of pre-release. And it's always the way, someone finds a bit of a bug when they come out of pre-release. And Dan was like mystified by it, because it was only happening when, what was it, Dan? You had the...
So I had it when I created a brand new .NET project, so a .NET new worker, and added the Brighter stuff. And when I ran it, it would just throw an exception saying something about storage, and it failed to register some DI stuff about storage. So I got the Hello World sample from the GitHub repository, and like downloaded that, ran that, it worked, compared like for like. There's hardly any differences between my project and this project. So I was like, what's going on? And eventually just like binary chopping it, trying to work out what's different between them. I worked out that if I deleted the launch settings.json file, it suddenly started working. So then when we were chatting about it earlier, we worked out that the launch settings.json file by default has, I think it was .NET environment development by default. So by deleting that, it meant that environment variable wasn't set. So it was that was breaking it. So there was something about that So I'll raise an issue afterwards as we discussed.
Yeah, so we think just for the listeners, we think it's because we've built some new transformers. One called a claim check. So messaging, if I don't want to put a large payload over messaging, one of the things I can do is put that large payload in some reliable storage, S3 or Azure sort of blob storage, and essentially just put the ID of where that is in the message body instead, send the message over the wire, and at the other side, grab it down from S3. So we make that seamless to you, right? You just basically put an attribute that says, hey, if my payload's over a certain size, offload it. That's called a claim check. And a claim check obviously needs a storage provider, right? Where am I going to write and read this stuff from? So we figured out, I think, that what's happening in the new release is that we register as part of our auto-registration in basically Host Builder. We register a whole load of our built-in types. And if you don't provide a storage provider, what Service Collection does in development is does this check to say, hey, can I resolve all of the dependencies that exist inside me? And it's simply saying to you, I can't, because for this one, I don't have a storage provider. Now, of course, you're not actually using storage provider in the stuff you were doing. That's why you haven't provided one. So yeah, it's an interesting issue. We'll have to go back and figure out what we do where you don't actually provide a storage provider. We need to think we shouldn't register those additional classes, but it's a good spot. So a good issue for us to deal with.
I'll include a link to that in the show notes to the GitHub issue that I raised.
Yeah, they can track us fixing it. Yeah, and the debate that will go on.
I got a README documentation issue as well, didn't I?
Yeah, you did. Yeah. We
so should be a QA person.
You should be. Yeah. So our documentation is now in Gitbook, and that's current and up to date. There is an old SEO optimized landing site, goparamore.io, and that's just a bit out of date. And the reason we haven't fixed it is we need to go into Squarespace and play with stuff there, and it's designed to be a nice. We had help from a graphic designer who did some OSS work with us, and we need to go in and basically alter it. And I always go into Squarespace, and it's great for graphic designers. It's not so good for ordinary folks, but I need to go in there and catch it up to date. Whereas Gitbook, because it's a lovely, just ties up to a Git repository and its markdown files. We edit those all the time because it's nice and easy, and it is a classic example of that barrier to entry, which doesn't seem like a lot, right? The difference between going to GitHub and alter the markdown files and go to Squarespace and alter the code in Squarespace, but it's big enough, it's a pain. And it may be that we need to move the landing page site out of something like Squarespace just because of that cost. And interestingly enough, we used to have our docs, the ones that are now in Gitbook, used to be in Read the Docs. But Read the Docs has an RST file format, and it's mainly a Python community site. And that in itself was a barrier to entry because we had RST files that developers just didn't, to the same extent, go in and do docs. So we often quite had to catch up, new features. But now we've got to the point where we feel much more comfortable saying to devs doing PRs, we can get you into a pre-release so we can test it out without you having the docs done. But we're not going to push you to release until we've got the docs done because it's now so easy to get docs done. And it's interesting, like that just enough of a barrier to entry means something stops being done because developers are inherently lazy, right? That's why we automate stuff for a living, right?
I was just going to say the same thing. With that one, I think I clicked on the wrong link in the README, and it took me to, like as you mentioned, the Paramore website, and I clicked on the get started, and it started talking about create a .NET Framework 4.5 application, and as it was going through the examples, it was talking about not using DI, and I was thinking, well, that's weird. You have to create a factory to new up your own stuff. So this doesn't feel right. So I went back to the README and found the other Gitbook page and clicked on that, and it's so much nicer, the documentation.
I mean, the really interesting thing that we benefit from, though, is so we still support backwards to all of that stuff. So one of our libraries are all net standard 2. Nearly all of them. I think one of them has to be net standard 2.1 because it's one of our abstractions over a database. I think that and the only libraries we can get are .NET Standard 2.1. But otherwise, our libraries are .NET Standard 2.0, which means they can be used equally from .NET Framework and from .NET Core. And we will try and maintain that as long as we can. We now have to multi-target because increasingly since sort of .NET 6 and .NET 7, Entity Framework team, I'm looking at you, Microsoft libraries have stopped usefully supporting Net Standard 2. I think in areas where they do have like Entity Framework, where there's effectively a .NET Framework product. But we continue to support that. And while we do give host builder support, so we work in the way that you would expect in a modern .NET environment, we also do support you coming with entirely your own DI framework, or even if that's home built. And the way we do that, we picked up on an article from Mark Seaman, who used to be one of the shining lights in the .NET community around dependency injection. And he really said, rather than at the time there was a big strategy a lot of us all used where we provided you with support for a given IOC container. What do I mean to do that? Well, if you think about it, what any framework has to do at some point is create some code you write for us. So you're writing, for example, we call a request handler. So a request is our generic term, underlying command or event, don't forget. And a request handler says, I'm the thing that gets called when you dispatch an event now. And we tend to want to derive from a class we call request handler. You can generally work to interfaces in Brighter, but we recommend there's usually a base class or something we recommend you use to simplify your life. And so we recommend you derive yourself from request handler. But all of those things require, basically because it's your class, some way of being created by us, as we essentially say, well, you've given us a command, we need to create an instance for the request handler to handle it. But it's your class. So we don't really know how to create it. We don't know what all the dependencies are. So what we need to do is let you create it. What we picked up from Mark Seaman is what we actually need is a factory that you implement. We don't want to abstract an IOC container. We have to abstract all of them. We want a factory that you will instantiate. So we have, for example, a handler factory, which is just a method, two methods on it, create and release. And we just say, give us one of those, right? Now, for with the host builder, we give you an off-the-shelf wrapper-around service collection for a handler factory. But you can support Ninjet, Structure Map, all those others by just creating your own handler factory. So anything you need, you can build. And so in our documentation, I'll explain to you how to configure Brighter at quite a low level, where effectively you throw away host builder and you say, okay, here are all these things that I need to basically provide to Brighter in order to get an instance working. And mostly it's around IOC and registration of components. But it's really useful. So internally, the other day, we had some old code that it was basically a .NET Framework project. It's, a good piece of kit. It's still doing the job it needs to do. There's not been a need to rewrite it at this point in time. But it was written in Structure Map. It's .NET Framework. We wanted to use Brighter support Kafka in it, and that's perfectly viable for us, right? I had to show the dev how to do it, but we can say, great, we can write a handler factory for Structure Map. We can then plug in Structure Map. We can run completely happily inside .NET Framework. I don't know how many of the other messaging transports out there today continue to have that level of backward compatibility, but we don't want to abandon our friends using .NET Framework until we are absolutely almost forced to by Microsoft, or there genuinely is nobody left out there who wants to use .NET Framework for their projects instead.
Yeah, that makes sense. I think it's worth just clarifying for the listeners, we are definitely talking about this is backwards compatibility out of the box. If you're doing a new project, you get all the DI goodness, and it just works.
Yeah. Host Builder is built in there. So you have to kind of go under the cover into what we do for you with Host Builder, right? But generally, most of the time, the only folks that have to understand that are the people actually contributed towards Brighter. So if you want to contribute towards Brighter, we tend to be really, I think, welcoming. So please come along. We can usually recommend some issues. The other thing we quite often recommend, because some folks want to come and work on Brighter, but they're not really use Brighter, and we say, write yourself some test projects. You'll probably create a few issues, like Dan did. Particularly around docs, you might find a few issues with docs, because we write the docs knowing how Brighter works. So it's really hard for us to get docs right for somebody who's new. So if you're new, you have tons of valuable insight for us that we can't get anymore, right? I know how Brighter works, so I fill in the gaps. Where if you're new and you read our docs and you go, that doesn't make any sense to me, that is like the best feedback we could possibly get, because it's told us what a new person thinks, and we can then correct and adjust with your help to make that better. So I always say to people, if you want to contribute towards open source, don't underestimate fixing the docs. And then we get to know you because you're helping us fix the docs and you're asking a lot of questions. And then typically you might say, is there anything I can take on? Often we basically have things like, well, you could write a transport. So a transport is an abstraction for a piece of middleware because there are ones we haven't got covered, right? So we could say, well, hey, we haven't got covered NATs or whatever. Go and write transport. And that's fairly straightforward because it's only really a couple of interfaces you need to basically build. Everything else you can pretty much get a first version cut. Then we can work you through a more standardized pattern of how we would do that, make it more robust with you incrementally. And that tends to be quite straightforward, or even wrap a database for us, right? And then that gets you further down the line towards potentially contributing, picking up bugs in the core platform and that kind of thing. So, and that's great. And we have had people, Paul Ridden, who currently is one of the maintainers, he appeared in our lives a couple of years ago. He was very enthusiastic, and now he is contributing major features to the platform. So, the rosters of open source projects change over time. So it's always great for us to get new people in, and their enthusiasm is infectious because when you get a new person on board and they're wanting to push features in, it excites everybody else on the team. Oh, great, let's really get back into this because people are interested, they're using it, they want to drive features in. The other thing I'd say is sometimes we see people build transports and stuff, etc., internally in their enterprise for stuff they want to use a brighter that we weren't supporting. And our big plea is please contribute that back, right? We didn't have an Azure Service Bus component for quite some time. And that was because none of the maintainers we had worked on Azure Service Bus. We were like, we really need someone to write a decent one who's using Azure Service Bus day to day. And we knew folks that had them and were using them, but they were inside their company. And we were like trying to basically twist their arms to go through the internal legal paperwork of being able to release their company source code to us so that we could effectively get a decent transport. We finally kind of got someone to basically give us theirs. Then Paul came along and fixed it up. It was great. But that's the other thing I would say is if you do write one of those internally, we would love to have them back because we know some of you out there have them but have just not pushed back into the main repo. And I understand it's painful sometimes that companies don't understand open source contribution, but our gratitude will make it worth it, I promise you.
I guess also it's not just about a whole new transport. It's about any fixes where if you work on an open source project, you do a fix, share that fix, push it back in, create a PR or something rather than forking it and just using that privately, that kind of thing.
Yeah. So for example, there are things where we've made a little decision. So we had one the other day from somebody where they wanted just to change the way that we wrote the headers of our message in Kafka. And it's something they needed and not everybody else needed. They could have just fixed that for themselves. But they gave us a PR, we put the PR out, it came out in the latest version, right? So that's an extensibility point they've created. And generally we look at that and say, well, it works for them. It's not genuinely, complicating or making stuff work. You don't need to, it's a thing you can kind of override if you want to do it. But generally my experience tends to be one person's done it. That might mean some other people want to do it. And actually, second or third time round on that, we may begin to see a generic requirement bubbling out of that we want to address as a team in a future version in some more interesting way.
This is a bit of a tangent, but you reminded me before when you talked about .NET Standard and like 2 versus 2.1, and I was thinking, what's in 2.1? And I was thinking spans, and then I thought, oh, that reminds me. I saw when I created my command, it created a property called span. So I thought, when I first saw that, I was thinking, why has it got a span in here? And then I saw the type, and it was activity, and it's like, oh, open telemetry kind of thing. This is, and I thought that's so cool that that's actually part of all of the different messages. So presumably that means that you get the open telemetry traces across these different services.
Yeah, so OTel's newish for us from V9, but we're very keen to have OTel in because it gives everybody, OTel's a great standard, right? And it means that you can disconnect yourself slightly from the given providers in that space. Provided your components are all using OTel, then they get to do value add on top, sort of dashboards and everything else. So yeah, we don't want to be a black box where if you are implementing OTel, that was it. It goes into Brighter, doesn't come out again, right? So we implement Hotel now. We will probably see further iterations on Hotel. It's a fairly basic level of support right now, and we may want to think about more as we go through. So if you are using Hotel and you want to give feedback or even make PRs to improve the way that Hotel works, first, feel free. We'd love to see that. It'd be great.
Yeah, I do love the way. I don't think it's quite there yet, open telemetry, but I think it's definitely so many things are embracing it.
It's definitely the right direction. It's like,
yes, definitely.
Another thing that, that's related to the topic we're talking about, which is async API, which if you've not seen, I've talked about it in a couple of conference talks, is effectively open API but for messaging, for asynchronous conversations. So on V2, it has some niggles because it essentially started as someone saying, I want to take the open API paradigm of format and do a asynchronous version of it, and there's a couple of, if you like, weird holdovers from doing that version 3 will fix. But that's a great example of a standard which even in V2 is worth adopting, because tooling and everything else basically continues to be built around and support that as you go forward will be really positive. We don't do this explicitly to support that right now, async API. We tend to have internally I always tend to recommend kind of a contract first model and scaffold stuff from it. But again, in V10, there might be something that we begin to think about. Do we want to basically give you some scaffolding tools to generate, brighter projects, given you've got some async API to feed us? We'll generate the relevant brighter projects as a kind of scaffold, and you can go away and build stuff from that.
Very cool. So going back to the different integrations that you mentioned, transports, so things like RabbitMQ, Azure Service Bus, I think there's an AWS one as well. And you also mentioned Kafka as well. So like a lot of them are like message brokers, where Kafka is more event streaming. Do you have to, as a user of Brighter, do you have to deal with those two things differently?
You as the user of Brighter don't know. There's an interesting, couple of thoughts there. So in Brighter's use cases, we would tend to assume that you are reacting to an event that you are receiving on a Kafka stream and do some work with it. We use underlying the Confluent.NET client, and on top of that, we do some management around offsets for you. We do that because Brighter has a standard way that it works with queues. That's that we don't, if it's a queue, we don't delete the queue message off the queue until you acknowledge, which basically means that your handler is completed, then we ACK, right? Now, we do actually ACK if you throw an exception. We don't regard an application error as a reason not to basically for not that message off the queue, unless you tell us that you want to throw what's called, I think it's a defer message. Exception, which says, actually, in this case, rather than basically just ACKing the message and logging, I've got an error, I want you to explicitly not to knack that message so that something else can pick it up, right? But otherwise, that tends to be our policy. And what that means is that if you're halfway through processing a message and you crash, it doesn't get ACKed. Right, and so your service restarts and you start working on that message again. So with a stream, you don't deal with queues on a message, you deal with basically sort of append-only log, you deal with records, and you're managing an offset. So what we do is we say, well, we won't ever increment the offset until you effectively get to that ACK point for us, right? And then essentially we have some work to basically commit offsets for you in batches to improve performance, essentially. And you can set batch size and tell us how often you want to commit your batches.
Do you persist that offset somewhere?
So Kafka will do that for you. The Kafka client tends to persist that. Nowadays, in modern Kafka, it's in Kafka itself. It used to be in Zookeeper, but I'm pretty sure it's now, I can't remember what version of Kafka that changes in, but it's in Kafka itself. I think pretty much, I don't know what the latest version of Kafka is entirely Zookeeper independent, or they're working towards it. I think the Zookeeper is only now used for leader elections by the cluster, but I don't quote me on that, I can't quite remember. So it works in that principle with Kafka, right? There are a couple of things that Brighter essentially doesn't necessarily, you can affect with Brighter, but not without a restart. One of them is things like, when I start consuming my stream, we assume read my offset from the store. If I haven't got an offset, basically start at the beginning. If you wanted to start reading at some point, you'd have to configure a publication to say start reading here and spin it up. So you'd have to effectively, you want to be able to configure that, you'd have to set an environment variable, read the environment variable, set the publication to do that. The other thing to bear in mind though with Kafka is the single-threaded nature of Kafka. If what you have is a Kafka stream or a partition into that stream, because if you have a lot of work, you partition it, right? Generally, if you want to read it in order, you're going to have to use a single thread. If you try to use multiple threads, the problem is going to be you're going to deorder, because I read the first thing, the other thread reads the second thing, but if that second thread finishes first, because that can happen in concurrency, particularly it works all the time in testing, but then fails when you're in production, you basically read the things out of order. So you have to use a single thread, right? And in fact, Kafka, when it works, enforces this idea that in a consumer group, only one thread gets to process a partition at a given time. Now, Brighter has what we call a single-threaded apartment model, for those of you who are old enough to remember COM. It's the same way, effectively.
Having nightmares still.
Yeah, that Windows Forms works when you see STA thread, and it's the same way that Windows works. And what does that mean? Basically, it means that Brighter uses one thread for a given message pump. So when you read a message basically off the queue, it's the same thread that effectively does translate the message, dispatch the message, and processes the message, then comes back to get something else basically off the message pump. And there's some buffering goes on in the background, etc., but we won't get into that because it complicates the model. And the reason Brighter offers you a single-threaded message pump is that if you only run one message pump, and Brighter lets you run multiple message pumps against a given subscription, but if you only run one message pump, your ordering would be preserved. And actually, it's surprising if you are single-threaded how high your throughput is, because you don't ever do context switching. So there's a naive model, which you see some middleware use, which kind of says, well, what I'll do is I'll have a thread pool, and when I read a message off the queue, I'll give it to a thread pool. And that works great for them at low volume if they're not worried about ordering. At high volume, what you see is that those messaging frameworks stall. And they stall because they're context switching, because they've read so many messages off the queue that they've generated so many threads from the pool that essentially they can't context switch between them anymore. And they can't apply what's called back pressure. So back pressure means you say, I want to limit the number of things that I'm reading to avoid this kind of problem. So we avoid context switching. We say you have explicit control over the number of threads that you will use to read messages off the queue. So another thing that you get problem with this, if you try AWS Lambda, one of your problems is going to be, for example, that they just introduced a fix for it actually, but it would determine the number of threads it was going to use to read the queue to call your Lambda with, right? You had no control over that, the rate you were receiving stuff, etc. But we let you control that explicitly. So it's a really deliberate choice to use a single-threaded model. We do have support for async pipelines where effectively we have our own synchronization context. So we, again, a bit like, Windows Forms used to work. But when you get to something like Kafka, I would recommend you use a synchronous pipeline with a single thread, because that's the only way you're going to preserve that ordering, right? As soon as you introduce, you go, I should be async. That's what I should do in the modern world. All bets are off, right? Because now we don't know what order you're going to process those things in. And if you use multiple threads, same problem. And we actually had a customer of Brighter, they had a really high volume soak test, and they threw tons of threads at it in Brighter and async, and it was really struggling. And we just said, switch everything off and go back to a single thread. And then it performed really well and basically ate its way through the queue messages. So it's that thing of just be a little bit cautious about, I understand we've all been taught, do async. I understand we've all been taught, hey, multi-threading is good. Just be cautious because it has side effects, right? And so we give you power, right, to make that decision that you want to do that, but we will do the right thing out of the box for you. If you ask us for a single thread and you have a synchronous pipeline, we will do the right thing by you, and it tends to perform well. Just as a slight aside on that topic, generally, in case you didn't know, if you have a solid state drive as opposed to a disk drive with heads and you are writing to it, normally a synchronous write is more performant than an asynchronous write.
I didn't know that.
Yeah, there you go. So
a new thing every day.
Yeah, because basically it turns out that it's so fast. By the time you set up basically what's happening under the hood, you're setting up basically a listener on an IO completion port, etc., in an async model. And generally, the cost of doing that is greater than actually the cost of the write was to the solid state disk in the first place. So async await has been a great thing for .NET, particularly in a post kind of Node.js V8 runtime. Again, Node.js single-threaded, right? Single-threaded basically with async, which is kind of the model we kind of advocate. But just be a little bit cautious because async means something, right? It means effectively that you're not going to get ordering. It means that you're going to have some context, some offloading onto an IO completion port, right? Some context switching. Is that always the right solution for you is what I'd say. So that's the only things to be a little bit wary of when you're using Kafka from Writer is just have a thought about things that might work out the box for completely unordered task-based style message queues. May not make sense anymore if you're reading a sequence of messages in order coming off a Kafka string.
Yeah, that makes sense. So I'm kind of like strongly aware of time now. So are there any bits big areas that you've not covered that we'd like to cover before we move on to dev tips?
I think it's okay. I mean, from your sense, do you feel that as a listener, you'd have an idea of what Brighter was and why you might want to look at it by comparison to any others? Do you think you've got an idea of that?
I think so. I guess the issue you mentioned before about because you're not a beginner to these concepts, it's hard to know for someone that is a beginner. Where even though I'm new to Brighter, I'm not a beginner to event-driven architecture and distributed systems, so I know all these concepts. So it's hard for me to put myself in the position of someone that's just never done event-driven architecture before. But I think so, yeah. And also, to be honest, the target audience for this podcast aren't brand new developers. It's more experienced developers anyway. So I think that's fine.
Cool. All right.
Cool. So shall we do dev tips?
Yeah. So the only dev tip I thought maybe might be interesting given the conversation we've had is if you're using Kafka, there are a couple of tools to recommend to help you. So quite often one of the things that, and there's a general application of this rule for when you're doing messaging. One of the things when you're doing messaging is, well, how much of my system do I need to basically deploy on my local machine or to some staging environment in order to test it, right? And really the answer is that there tends to be a preference that what you do is you test kind of faking messages in and listening to messages out. You don't construct the whole pipeline. It's a contract and you say, hey, I should be okay if provided I send the correct thing or either receive the correct thing and send the correct thing. So how do you send kind of messages easily at a command line? It turns out there are normally tools off the shelf you can get which let you basically generate a message at the command line or receive messages at the command line. So in the Kafka case, there's one called KCAT. KCAT's very useful. It essentially lets you basically send and receive messages at the command line. It can be great for figuring out why is my application not seeming, is it working or not, right? You can pretty much, when you get KCAT up, send something, say, and then receive something with KCAT and say, okay, that went to that topic. I can receive off the topic. Okay, now I'll run my service because I know I've got some topics on there with KCAT. Can it receive them? Okay. And I think that works really great with KCAT if you've not used it is JQ.
Yeah, so good.
Yeah, exactly. So JQ, for those that don't know, is a little tool for basically parsing JSON, essentially, a little command line tool and manipulating it. And occasionally I think I should just give up writing any other software than using curl and JQ or KCAT and JQ. I'm sure I can build out applications that way. But that can be really helpful. So if you read a message off the wire, particularly if you have a JSON payload, something like JQ with KCAT means you can then parse it and see what you got out and test that you're producing the correct thing. So those kind of tools are fantastic. I mean, and generally in an environment, you quite often find CLI-based tools. I mean, AWS has AWS CLI. You can push messages onto SNS. You can read them off, right? And again, you can use JQ with it. And you can write yourself some nice little scripts that are the equivalent of doing curl if you were HTTP API dev or Postman or whatever your tool of choice is for doing the kind of HTTP testing in simple scripts. And that's really valuable. So that exists in messaging too. And I occasionally find people who are new to messaging don't spot that there are curl equivalents out there that do that work for you. That's my dev tip.
Very cool. Yeah, with the JQ, have you seen jqplay.org, I think?
Oh, no, I haven't. What's that?
JQ, yeah, .org. Oh, no, it's not doing anything. It looks like it's down. Oh, that's a pain. I've got an unknown server error. That's not very good.
I've got jqplay.org from Google, HTTPS. It does seem to be down today. I wonder if I can get Google to give me a cached result.
It's one of these ones where you can basically have like paste in some JSON. Do you know, like you get regex web tools? It's like that for JQ, so you can test different JQ queries, and it's got like documentation and and then it's got like a cheat sheet at the bottom. It's just quite cool, but it's a shame that's down actually.
Yeah, I can see there's a GitHub site that's basically there, but it does seem to be down. I guess maybe someone's doing a release or something.
Maybe. If it's not back tomorrow, I'll reach out to the organizer and let them know.
Yeah.
Oh, that's a shame. So my dev tip is like completely unrelated to this topic, but I think I just run out of dev tips, so just because I got to think of one for every episode. But I don't know. I'm sure all the listeners have heard of ChatGPT and have been playing around with it, and it's kind of it's like maybe tried a few things on ChatGPT and thought, oh, that's awesome. How's it done that? And then forgotten about it. And my dev tip's just to don't forget about it and actually use it as a tool. And quite often I'm finding that there's things that it gets wrong, but if you know enough about what you're asking, that you can really use it as a tool to get you started. And also it's brilliant for idea generation, just having a conversation with it. It just gets the brain ticking. And I don't know, I'm trying to use it more and more for different things. And I had a period where I first tried it and I was like, wow, and then I forgot about it, like I mentioned before. And then I stopped using it. And now I'm actually, well, why did I stop? Let's just use it as a tool like you use other tools. So, yeah.
Yeah, I like all those language model tools like ChatGPT and Copilot. And one of my recommendations, going back to the TDD talk, is if you're doing, classic Kenbeck TDD, as I would call it, and you're doing red green refactor, one of the ideas is that as you go from red to green, you don't focus on making high quality code. You focus on solving the behavioral problem that lies in front of you. So you are explicitly enjoined to be sinful, right? Go and cut and paste code from Stack Overflow and that kind of thing, right? Because your tests are there to tell you when you get to something that passes, and the refactoring step is about turning that into clean code. So one of the great things I tend to recommend is that use tools like Copilot or ChatGPT in that red to green stage, right? You've got a behavior, you've got a test that tells you whether it's right. The behavior, if it's well expressed, can be something you put into ChatGPT to tell it basically generate some code to pass this, right? It will give you something. And then because you've got a test around it, you can then go and refactor once you get the passing solution and say, well, that isn't how I do it. And, that seems a bit weird and funky, right? Then you can refactor to your heart's content, because what you wanted was the hint on what's the algorithm that passes that problem. And then effectively you can move forward, all the time protected by the test. The other thing is that tests tell you, did ChatGPT lie to me, or is it actually is that a solution to my genuine solution to my problem? So I think it's ideal in that red to green step, and you can feel, I think, comfortable using it, because let's be honest, we would cut and paste code from Stack Overflow at that step anyway, right? It's the great dirty secret of all software engineers, right? Is we Googled the answer, right? So ChatGPT is just Googling the answer with slightly more convincing bullshit. But TDD protects you basically in that step, right?
I'm curious now, and I haven't tried this so far, but I'm going to load up ChatGPT. Honestly, I haven't tried this, so I'm just curious. Oh, right, writer, command handler.
Oh, yeah, interesting.
Right. That's right. Hello world to the console, to the standard out. Let's see what it says there. Oh my God. Assuming that you're referring to a command handler for a programming language, there is an example. Oh no, so this is writing something in Python. So let me stop generating. No, I meant the writer. Right.
Did you say .NET?
Written by Ian Cooper. Oh, something went wrong. Try and reload the conversation. Oh, that's not...
If you say .NET, I mean, you can also use Paramore. So it's named after the song by Paramore, Paramore, Paramore Brighter. That will give it a slight, that's the NuGet package. That might help it.
I'll have to refresh the page because it, it said, no, I meant the Brighter, written by Ian Cooper. And it says, oh, my apologies for the confusion. Here's an example of a Brighter command handler that writes hello world to the console. Oh my, right, it's done it.
Wow, cool.
I'll put a screenshot in the show notes, but it's written it in C#. It's using the NuGet package, and it's explaining it. So it's written the code sample, and it's explaining it to me.
Awesome.
It's saying how. Oh, now it's telling me how to actually send a message using the command processor.
Wow. Awesome.
That's insane, isn't it? And honestly, I didn't try that before. It was kind of, but I've been trying it for this kind of thing, but not for Brighter. But,
to be honest with you, we should probably use it to help us write some of our documentation, because probably it's doing a better job at writing the docs than we are. I hadn't really thought about that before, but I do wonder if that's a sweet spot for open source projects. Is please write documentation for my project, but I'll have to try it later.
That new chart, write some document. So it worked out Ian Cooper, so I'm going to use that term. Write some documentation on Ian Cooper's Brighter library. Right, it's doing it. It's so fun. It's writing a whole bunch of stuff talking about CQRS and command dispatcher patterns, and it's just, oh my goodness me, that is ridiculous.
My work is done, I guess. You have to send me that in an email. I can lift bits of it to improve our docs.
Oh dear.
There's a new hot tip for all the Brighter devs. Then basically, I have to post back to them saying, guys, when you finished your feature and you need a doc, get ChatGPT to help you. That's good though. I'm glad that you can go and ask ChatGPT questions about Brighter. We're it's nice to know that we made it to ChatGPT's radar.
I just wonder what this is like now, and this is only like this. It just feels like this AI stuff has suddenly kicked off. What's coming soon? Then this is just.
Yeah, so I described it to somebody else. My analogy is like this, right? Once upon a time, in order to effectively use a database, you had to, devs had to know a lot about data structures, algorithms, that kind of thing. And at some point along comes SQL and relational data stores that are pretty reliable. And that happened in my development career. And suddenly it became really easy to basically start using databases and query them, and the whole relational database explosion took off, right? And it didn't remove the need for us to be devs. It just changed the way we were working at suddenly a higher level of abstraction, right? And I do wonder if we're almost at the beginning of a similar revolution where there's a higher level of abstraction we start dealing with. So there's a really interesting one some people were pointing to, which is almost this idea of saying, language wars, right? Where you go, someone says to you, can you write this thing in TypeScript? And you're kind of like, oh damn, I only know C#. They're quite close though, aren't they, right? So I'll just write it in C#, and then I'll tell ChatGPT, can you turn this into a TypeScript program? And it will. Which is really kind of like, well, I need to know one programming language, because whatever the programming language you're using, I just tell an AI tool, convert it across for me, please.
I think also that we're talking about this from developers' point of view, but as in with other big shifts with technology, things like the smartphone and that kind of thing, how that completely changed everything, where just everyone had a smartphone. That in 5-10 years' time, is everyone, not just technical people, just going to be communicating with the AI and not even thinking about it.
I think everyone will use it like a smart assistant. So, another analogy you can think about is word processing. So once upon a time, when I was at university, this is quite a number of years ago, you wrote essays by hand with a pen. I took, when I did my computing degree with the university, so I did first year was in English, so I went to the master's at the university. Even then, you wrote computer programs with a biro and a pen on a piece of paper writing exams. But when used to write long essays, one of your problems was you'd do maybe a first draft, you'd read through it, cross some stuff out, change stuff around, do a second draft. But drafting was a whole hideous exercise because you didn't have the time to go, oh, I wish I put that paragraph here, and it made much more sense if I did this and did that. Once word processing technology came along, suddenly all of us, our capacity to write better documents, because we could chop stuff around, edit it, process it, improve dramatically. Now, it wasn't like a thing which we all kind of consciously remember, which kind of goes, well, we were all replaced, we replaced all these jobs. I mean, typing pools basically did go, right? So typing pools basically vanished. We don't consciously think about that. We don't even consciously think today about the fact that we use word processors all the time to help us write stuff. And my gut is that a little bit, it will be one of those kind of revolutions in that 5-10 years time, we will all be working slightly differently, but we'll just regard it as more efficient in the same way we regarded moving to word processors over writing things by hand as just easier. And then there'll be old school people who are sitting next to you going, well, I remember we used to write all that by hand, and people will roll their eyes, and go, okay, boomer to them. But I'm not panicky about it. I think it just hopefully will remove some drudgery that lets us move faster and more productive about things. My classic example would be something like, I want to basically store a file to an S3 bucket on AWS. Generally, I don't do that often enough that I'm not going to look it up every single time. I'm going to read the docs and do stuff. And that process, it's not like I'm deploying super expertise. I just read the docs, figure out how to apply the docs in my situation and do it. If ChatGPT can do that for me, I've not really lost anything as a dev, right? It's just read the docs for me and said, here's the code you need according to your comments to make that happen. And I'm like, great. And hopefully, if we begin to knock down the doors on that stuff and we don't panic about it, we'll all end up doing what we really want to do, which is focus a lot more on the domain model problems that our customer has. And to go back to Brighter, right, which we introduced at the beginning of the conversation, right, it's this idea of, I want you to write the request handler. I don't want you to have to deal with messaging, right? Or in the same way that we completely accept, I'm just going to write a web API controller. I don't want to have to deal with basically, TCP IP, listening to HTTP, parsing requests or whatever. All that stuff, we completely accept we don't do it anymore. We focus on writing code that solves customer problems, and I think that's where we'll get to.
Yeah, I think developers that are scared of change are going to have trouble, but any developers that's agile and willing to learn new stuff and change how they leverage tooling and take advantage of this kind of stuff, I don't think there's that much to worry about. Like, our jobs are going to change in the next 5 years. Our jobs are going to change dramatically, I think, but we're still going to have them.
Yeah. I mean, I think I always say, look, typing is the least important part of the activity in programming. It's about basically building models of things and automating those models. And, we have had a long period where we just unnoticed to us got through, if you compare, the IDE we have today for a relatively low price with, the way we used to write stuff and have to debug stuff, etc., there are incremental productivity improvements for all of us. We don't really look back on it and go, oh my God, all those devs lost their jobs because we had debuggers, right? We just move with the times and learn how to do stuff in a new way. And I think that I just think, like I said earlier, most devs are inherently lazy, provided they feel that they still get to be devs. They just get to basically automate the whole lot of boilerplate stuff out of the way. I'm sure they'll be fine, right? Interesting. I use Copilot, and I was writing a new feature for new transform for Brighter about encryption. It's not out yet. You'll see it at some point. But I wrote the test, and I went to write the implementation, and Copilot just said, "Oh, I'll try offering you the implementation." Now, what's weird about the implementation, right, is that it just offered me the skeleton of what this could look like, and it didn't actually have any, code in most of these things it was calling, or whatever, actually. I looked at it and I thought, that's not bad. I mean, it's not bad. It's not exactly what I want to write, but given what it knew about what I wanted to do, contextually was reasonably small. Its ability to go, oh yeah, you're probably going to do some AES encryption and whatever, effectively, it was like, that's not a bad stab. And if I'd been really stuck for how to get started, that would have been an enormously good starting point. Yeah. So I think just don't be frightened of it. Just treat it as your pair programming friend.
It's another tool that you can take advantage of to be more efficient. But I do like that, actually, especially with the chat GPT style things where you can have conversations and it keeps context. Treating it, as you say, your pair programming with us and having conversations with it. I'm kind of strongly aware that this is going to be the longest episode ever, so we are going to have to wrap up. Also,
you can decide which of these bits and pieces you want to actually put in your content, right? I generated content for you. You decide what's in, right?
I'll ask ChatGPT. Can you edit this for me, please?
Yeah, or you can even chop some bits out and release them as 10-minute segments, right? 10 minutes on ChatGPT if you like.
Well, to be honest, it's all been good. So I'll just make it a long episode. It's all good. It's all fine. But we should probably wrap up.
Yeah, we should do.
Before we do, where's the best place for listeners to reach out to you?
Oh, that is a good question nowadays. Because I would have just said you can grab me at iCooper on Twitter, and I do keep an eye on Twitter. I'm also iCooper on hachyderm.io, which is a Mastodon server. I tend to be more active on Mastodon. I check Twitter, and if you're talking to me, and I will occasionally scroll through the feeds of people that still on Twitter. But I tend to post more on Hachyderm, the Mastodon server nowadays.
It's funny, I did the previous episode recorded this morning, and the guest was saying exactly the same thing, just like at the end when we're talking about contact details, he's not really using Twitter anymore, and he's now using Mastodon. And I'm kind of using both, but I'm still more Twitter probably, but it feels like everyone's moving over, especially in our space.
I think that some communities, so tech, another one I'm in tabletop role-playing games, there's definitely large numbers of people that have moved. I think some people that haven't moved are either it doesn't make any difference to them because they're not active, and therefore they're as passive consumers, they just want to feed. Or some folks that have real investments in their profile on, say, Twitter, big audience, and they won't get that same audience immediately over on, say, Mastodon, and they've got to figure out how to do that. And Mastodon's different because you don't have a feed that essentially Mastodon curates, so it won't promote things. You don't get that thing where, hey, this tweet, everyone's looking at it and talking about it, engaging it, or stick it in your feed because it's on the topics you like and stuff. So you can't get that kind of organic stuff. You either have to be a hashtag, or effectively somebody has to boost you to people other people know. For some of us, that's one of the attractive things about Mastodon, right? You don't see some of those, you'll never guess what happened next, kind of clickbaity threads to try and push engagement. It's much harder to do those, and there's no algorithm to promote you, which is like early Twitter before the algorithm crept in, which is why people talk about Mastodon as being early Twitter. What they mean is it's before the algorithm began to dominate everything. But at the same time, that also means if what you want to do is reach new audiences and that kind of thing, Twitter has a huge advantage because the algorithm helps you. So part of my guess is that they're not necessarily mutually exclusive. That Mastodon is where you go for a conversation, and Twitter becomes more where you go for broadcast.
Yeah, maybe. One thing I like about, and I said this in the last episode to David Wengier was on the last episode, and one of the things I really like about Mastodon is that you can follow hashtags like it was a user.
Yeah.
And so I'm finding that when I'm posting on Mastodon, I'm now using a lot, like really thinking about the hashtags I'm using, because I know people are following those hashtags.
Yeah. And I found really useful is, actually I didn't really realise until Martin Twaits told me, on the advanced web interface, you can effectively, a bit like TweetDeck, create columns that basically follow given hashtags. So I've got a column for .NET. I have a column that permanently follows the .NET hashtag. And that's really great because actually I see a lot of .NET people and .NET stuff that on Twitter I might have been frightened to try and, follow that kind of like number of people, but it's great. I just got a hashtag. I follow them. If you're posting on .NET, I tend to see your stuff, right?
Yeah, it's a good tip, that advanced thing, because it's not obvious when you first go to it, but yeah, it's just a checkbox, and suddenly you get like a TweetDeck kind of much nicer interface. Yeah.
I don't know why it's a hidden secret. I guess they feel it's intimidating for average users, but it feels like something they should surface more. That, click this button and you'll get a multi-column interface, and you can follow hashtags really easily.
Yeah, definitely. Right, so probably should wrap up given the time.
Right.
But thank you so much for joining us. It's been amazing having you on.
Hey, lovely to see you again, Dan.
Yeah, you too. It's been a while.
Yeah, see you something soon.